again. Welcome to the second demo, which is related to Red Hat OpenShift GitOps. We'll start with logging in into our OpenShift environment. This environment is prepped for GitOps workshop with some pre-existing project resources. Make sure we are in the developer perspective. OpenShift conveniently provides a web-based terminal that includes many of the necessary command line tools you need to interact with. You can open the web terminal by clicking its launcher button to the upper right menu near your username. Once the terminal is launched, you'll see it at the bottom of your screen. We can pop out the terminal so we can see it on a full screen. Let's head back to the console. An Argo CD instance has already been deployed into the OpenShift project under user1 Argo CD. This is one of the benefits of the operator-based mechanism that OpenShift uses. It's easy for users to deploy software and solutions. In topology for our Argo CD project, we can see the Argo CD deployment. The Argo CD repo server is responsible for cloning Git repositories, keeping it up to date, and generating manifests using the appropriate tool. The Argo CD application controller uses Argo CD repo server to get generated manifests and Kubernetes API server to get the actual cluster state. The Argo CD server is a stateless server which provides the connectivity to Argo CD. Redis, which stands for Remote Directory Server, is a fast open source in-memory key value data store. Argo CD DEX server is used for authentication. While Argo CD generates the default admin user and a random password when first deployed, you can also configure Argo CD to use the OpenShift authentication. You can connect to Argo CD using this user account via the CLI or web console. In this workshop, we'll only be using the web console. There are multiple ways to find the URL for Argo CD. For example, clicking the pop-up icon, looking for the URL in project resources, or querying the routes via CLI. Let's use the pop-up icon. We'll use the OpenShift login credentials to log in into the Argo CD instance. This is the Argo CD web UI. As GitOps implies some relationship to Git, we'll need to get the manifests from the repository somewhere. We'll be using the repository that contains this demo and its documentation as the source of the manifest that defines the application state. Let's clone the Git repo in our web terminal. We'll deploy a sample application using Argo CD, but let's review the application manifest first. This is the deployment resource. We're creating a container using this image and also specifying some environment variables. Then we have a service resource with port and protocol info. And finally, a route based on the service. A managed collection of manifests is known as an application within Argo CD. Therefore, you must define it as such using an application CR or application custom resource in order to have Argo CD apply these manifests in your cluster. Let's review the application manifest used to deploy this application and break it down a bit. The destination server is API endpoint for the cluster where Argo CD is running. In this case, using the locally resolvable URL for the cluster. Here you are installing the application in Argo CD's default project. Argo CD's concept of project is different than OpenShift. Here you are installing the application in Argo CD's default project, not the OpenShift default project. The manifest repo and the default path within it where the YAML resides. And then the sync policy is set to automated. It will automatically prune resources that have been removed from the Git repo, but it will not automatically correct resources that deviate from the definition stored in the repo. That is, manual changes made using OC or kubectl will not be hailed. Let's deploy the application. We'll just update the username variable and create the application. Let's have a look at the application in Argo CD. Clicking on this tile takes you to the application details page. You can see it is fully synced. We can verify that the resources were created. Now that the application is deployed, let's launch the app. It's a simple application which just shows you some blue dots. Let's introduce a change in the application environment. We'll patch the live deployment manifest to change the color of the bubbles in the application from blue to green. Let's see the rollout status of the deployment. And let's refresh and see the application in action again. Let's have a look at Argo CD. It's showing the application is out of sync because we had set the self heal to false. It would not automatically heal the drift caused by manual changes. Let's initiate the sync from Argo CD, and it's complete. So let's go back to the application and see the blue dots again. You can set up Argo CD to automatically control the drift by setting the self-heal property of the application manifest to do so. We can either do it directly from Argo CD or via web terminal. Let's use the web terminal for that. Let's make the change again and see what happens. We can see that Argo CD is automatically controlling the drift of the application. And we can see Argo CD initiating the sync when it detects the drift. In this part of the demo, we'll deploy a sample application with the database, and apart from the deployment files, the sync waves are used. A sync wave is a way to order how Argo CD applies the manifests that are stored in Git. All manifests have a wave of 0 by default, but you can set these by using sync wave annotation. As you can see, the sample application that we will deploy has several waves. Let's have a quick look at the manifests. First, the PostgreSQL has a sync wave of 0. Then the PostgreSQL service has a sync wave of 0 as well. Secondly, the database table creation has a sync wave of 1. The to-do application deployment has a sync wave of 2. The to-do service has a sync wave of 2 as well. And then the to-do route has a sync wave of 3. First, the PostgreSQL deployment will be applied. After that report's healthy, Argo CD will continue with the rest of the resources. Argo CD won't apply the next manifest in the wave until the previous report's healthy. Let's take a look at the to-do application manifest file. As before, we'll update the username and create the application. And in the Argo CD, you can see the application being deployed. If you look closely, you'll notice the application is deployed sequentially due to the sync waves. The application is fully deployed and synced now. This is the end of our GitOps demo today. But before we close, let's have a quick look at the new application. This was just a high-level demo overview of what we can do with Red Hat OpenShift GitOps. I hope this was helpful as well. Thank you for watching this.